covered. What kind of data is finally received? When to start restructuring? After receiving the last message. We can put it together like a puzzle. So this is a shard of our 3-layer it. Including that we can finally restructure. A mechanism for messages. Alright. Is our layer. I'll go on. Here's a time to live. What does this mean? For our 3-tier. It creates a loop problem in the future. Have you heard of the ring road? The future. What might happen to the data? During my entire data transfer. My message. Keep going in circles and circles in the web. But I just can't reach my destination. Then our TTL value. Time to live. It's about the future. How many 3-tier devices have I passed? In fact. Tell everyone. What is the TTL value that you are probably most familiar with? Is 255. In fact. For different manufacturers. Different series. Different models of equipment are not the same. 64, 128, 255. Not fixed here is 255. Tell everyone this. It's just that most of you see 255. So in the future if here. For example I am 255. Then every time I pass through a 3-layer device. In the future. I would decrement this value by 1. For example. Now our network topology is like this. Engineers may have planned wrong. Then I generate a data in the future. I think go right. It also thinks go this way. Every time we check the routing table. It turns out that the data is always going to the right. This is very easy to appear when we configure unfamiliar routes. It's very easy for this to happen. Including your future to the NP stage to learn OSPF. The loop problem is a very difficult problem to solve. Let's take a look. If it is said that a number is generated locally. My TTL value is 255. Then every time I pass a 3-layer device. I will subtract 1 locally. Reduced to 254. Here 253. Then 252, 251, 250. Turn around. Turn around. Go to the end. For example. The device received a TTL value equal to 1. In my local. 1 minus 1 equals 0. If I subtract it locally. It is equal to 0. I will throw this message away. It is equivalent to us passing the TTL value. Can temporarily prevent or suppress this round of loop problems in our network. It doesn't break the loop. It can only say to temporarily remove the loop. Once the next time you send this message again. I'll start turning again. Only. Finish 255 times. I'll throw this one away. This message will not be forwarded. In the network all the time. That's all I can do. Let's go down and see that there is a protocol. What does the agreement mean? The protocol is the identification of the upper layer protocol. We identify services above the network layer. So suppose in this. In the future we will learn a protocol called ICMP. By default it is a. If I fill in 1 in the protocol field on the 3rd floor. Represents my upper layer is an ICMP. Everyone knows the employment of tracer. That is our trace ROS. In fact. It is our trace. It's all about our ping command. ICMP is based on the sending of one of its messages. This is the protocol. In the future we will also learn about UDP and TCP. Because the upper layer of our network layer is the encapsulation of the transport layer. The 2 major protocols of the transport layer. If it is TCP here is 6. If UDP here is 17. It's here if you fill in 17. It means that My upper layer is using the UDP protocol. Sent to the next 3 floors. After dismantling, I will send it to the upper layer protocol for processing. Just send it directly to UDP for processing. In the future we will also learn an OSPF. It also works on top of the network layer. But it doesn't belong to the transport layer. We will talk about it later. Then the protocol number it identifies here will be 89. If it is 89, it means that the upper layer is now an OSPF protocol. It is used to identify the upper layer protocol. Alright. Let's go on. There will be a header checksum in our entire network layer. That is, the third layer also provides a verification function. Can verify the integrity of the 3-layer data. Similar to the second floor. But the algorithm it uses is called 2's complement summation. Not the same as layer 2 CRC. But it is also possible to check the integrity of the header. This is enough to understand. Know that it has an integrity check function. It can also be checked. Next we compare the important parameters. Called source IP address. A called destination IP address. These are the 2 key parameters of our 3 layers. Must remember. We will have source and destination IP. When we encapsulate at 3 layers. It's like when we encapsulate 4 layers. There will be the same source and destination ports. You must remember the most core parameters of each layer. Layer 4 source and destination ports are its core. Layer 3 source and destination IP is its core. This is our layer 3 source and destination IP. We go down. Not to mention this option. Because basically we can't see it. Unuseful. Including learning IE stage. We rarely use this option. In the future, the source and destination IP will be the time when the data is sent. My IP and peer IP. Say 2 devices. I am 1.1.1.1. It is 1.1.1.2. Then I am here. The peer is 1.1.1.2. We send a data for data communication. This is a piece of data that the network layer encapsulates. Let's go down to the data link layer. For the data link layer, we will only cover one Ethernet LL. Let's just take a look here. For our data link, there is a frame header and a frame trailer. Then the middle. In fact, this passage is our packet. Also through all our. After several layers of packaging, we call it packet layer 2. Plus 2 layers of needles and true tails. This is called the data link layer. After adding, we call it a data frame. It's a name. Everyone needs to know first. Data link layer. There are actually 2 frame formats. Something called Ethernet LL. A type of 802.3 called IEEE. Here to tell you about IEEE 802.3. Another data encapsulation standard. For such a standard, we see less. We use more Ethernet LL. Its structure is also very simple. There will be a type. That in this type, we also identify the upper layer protocol. Everyone can see. If we choose 0800 in this, that is a hexadecimal number. Identify my upper layer data volume. What's on the 6th floor? Is it 3 floors? On behalf of the 3 layers we use the IP protocol. If now I am using 0x0806 here, identifying what our future upper layer will use is called ARP.